ultraviolet rays. Now, the radiations of ultraviolet, that is also known as UV radiation, is produced by special types of lamps and very hot bodies. So it is basically need an extra treatment, and we can also take important source of UV radiation as the sun. And the most of UV radiation is absorbed by the ozone layer. And this ozone layer stops the UV radiation to come towards the earth. And due to this, there is an altitude of earth is about 40 to 50 kilometers from the surface of earth. So this ozone layer is at 40 to 50 kilometers. Now UV radiation is harmful to human body. And also some kind of UV exposure induces more production of melanin, and that causing tanning of the skin. Means some kind of points or black dots are availing on your skin, and ordinary glass absorbs most of the UV radiation. And also one can get less tanned or sunburn through the glass windows. Now, when a large amount of UV radiation that is produced by welding arcs, and hence welders use face masks with dark glass windows, or they wear special glass goggles to protect their eyes because it is very harmful to eyes even. The UV radiation is having the wavelength range of 400 nanometer to 0.6 nanometer. And using this you can calculate the frequency range also from the equation delta is equal to C by F. Thus, the UV radiation can be focused into very narrow beams of for very high precision applications such as LASIK, and the full form you have to remember, laser assisted in situ keratomycetes. So this is the basically an eye surgery. In some of the water purifiers, UV lamps are used. Also, the depletion of ozone from the UV protective ozone layer by the presence of, so which particular element is present in the ozone layer which absorbs most of the UV radiation? So that element is CFC. It is known as chlorofluorocarbons. So such kind of gas, for example, I am giving you freon. So freon gas is a matter of international concern and which is present in the ozone layer. Now we will see the next region. So the next region is X-rays, and these X-rays can be produced by bombarding a metal target by high energy electrons. So what will happen in this way? When the large amount of high energy electrons are bombarded on a metallic target, then there will be some reflection back, and such kind of reflection will give us the information about many interior parts of any object or any body that we will see later on. But the X-ray spectrum, or the we can say bandwidth of the spectrum, is from 10 to power minus 8 to 10 to power minus 13 meter, and this is beyond the ultraviolet region, and X-rays are used in many applications. So some kind of it is medical, to find the fracture in bones, for treatment of cancer, So this is all about its application. But X-ray can damage or destroy living tissues. Which are actually present in our body cells, or it can also affect organisms of our body. So we have to take care by using X-rays for unnecessary or overexposure of it. So this is all about X-rays, and now we will see the last region of electromagnetic spectrum, that is gamma rays. So this is the last region of electromagnetic spectrum, and this particular region are produced by or such kind of waves, nuclear reactions, and such kind of rays are also produced during emission of some radioactive nuclei. Next, gamma rays lie in the upper frequency range of electromagnetic spectrum, and their wavelength range is given by 10 to power minus 10 meter to 10 to power minus 14 meter, and the applications of gamma rays are in medicine, and to destroy cancer cells. And now we will see the table for different types of electromagnetic waves, which is here given. First of all, the types are given. So the radio wave is first, having the wavelength range greater than 0.1 meter, which we have seen earlier. And the production is taken place by rapid acceleration and deceleration of electrons in areas. And how can you detect such kind of radiation? So you can detect from receivers areas, that means conducting wire. Then comes microwave, having the wavelength range of 0.1 meter to 1 millimeter. The production you can done by these generators, klystron, magnetron valve, gun diode, etc. And how can you detect? By using point contact diode. Now next one is infrared. 1 millimeter to 700 nanometer its wavelength range, and it can produce by vibrations of atoms and molecules, and you can detect it by thermopile, bolometer, infrared photographic film. Next one is visible light, which is very sensible to us, having the wavelength range 700 nanometer to 400 nanometer. You can produce this by it is naturally available, but if you want to produce, then electrons in atom, they will emit when they move from one energy level to a lower energy level. If you want to detect it, then the eye, photocells, photographic film, photodiode, that is LDR, light dependent resistor. Ultraviolet, 400 nanometer to 1 nanometer, and it can be produced by inertial electrons in atoms moving from one energy level to a lower energy level. So in this both the cases, the electrons are moving from the higher energy level to lower energy level. We can detect it by solar cell, photocells and photographic film, and then comes X-rays. having the wavelength range 1 nanometer to 10 to power minus 3 nanometer, and it can be produced by using X-ray tubes or inner shell electrons and atoms. Photographic film, Geiger tubes and ionization chamber can detect X-rays as well as gamma rays. Gamma rays are having the wavelength 10 to power minus 3 nanometer, and it can be produced by radioactive decay of nucleus. And with this, our chapter number 3 is over.